Hi, this is Mrs. Vrobel. This is the last section of the Chapter 12 States of Matter Part 4 video. In this video, we're going to talk about how properties of liquids can be determined just by their intermolecular forces. Also, we're going to precisely determine the type of solid based on the unit particle in that solid. And then lastly, we're going to identify the phase changes that occur using a phase diagram. Okay, liquids. So we talked about the different types of intermolecular forces. So if we have hydrogen bonding, we potentially could have higher viscosity. And viscosity is the resistance to flow of a liquid. The larger the molecule, the greater the viscosity. Honey is a polymer, and it tends to have a very high viscosity. And that's because it has a longer chain. However, if we were to heat up that honey and put it in the microwave, I don't know if you're like me, I do that occasionally, you'll notice that the viscosity actually decreases because you're adding energy and causing the molecules to overcome their attractive forces. Okay, another property within liquids is called cohesion, and that's the force of attraction between identical molecules. So the water molecules in this glass are experiencing cohesion, they're attracted to each other. We could have adhesion. You might notice that when you're drinking a glass of water, there's little droplets that cling to the sides of the glass, and that's what we call adhesion. Now we also have what we call capillary action, and you might notice that in a narrow tube, the water actually will flow up the sides of the glass tube, and that's due to cohesion, the water molecules attracted to each other, and adhesion to the sides of the tube. Okay, here we have boiling temperature of a liquid, and I have a couple Erlenmeyer flasks here. Now when we look at water, liquid form, it actually doesn't exist as just a liquid. It will have vapor molecules above the liquid. And when you look at boiling, it's actually the temperature at which the molecules that are above the container, they exert a pressure, and that pressure is equal to the atmospheric pressure. Now, if you were to go to a higher elevation, maybe Denver, you might notice that there's different cooking times. That's because water boils at a lower temperature, and we'll talk more about that in class. All right, so we've discussed liquids. Now we want to finish up with solids. Now, solids are essentially particles that are strongly bonded to each other. They have a very strong attraction, and they're in fixed positions. Now, this doesn't mean that they don't move. They're actually vibrating as they stay in that fixed position. So what this does is it actually gives us a definite volume and a definite shape for that solid. Now here are some examples of crystalline solids. So we've talked about a few of these in class. We've talked about ionic. So ionic is composed of ions. Notice that they're hard, they're brittle, they have high melting points. They have a very strong attraction with themselves. Then we have molecular, which is essentially molecules or covalent bonds. Notice that they're soft. They have moderate melting points. They're not as strongly attracted to each other. There's also covalent network, and I'll talk more about diamonds in class. And then lastly, there's metallic. So metallic, they're soft to hard. They have low melting points, and their attraction is not as strong as ionic. All right, lastly, we're going to talk about phase changes and phase diagrams. And this is actually review. Here we have an example of different types of phase changes. So notice we have melting, evaporation, sublimation, condensation, deposition, and lastly, freezing. We're going to now look at what happens to the energy with these phase changes. Endothermic. Endothermic means it takes in heat. So the interesting thing is, melting is endothermic. It takes energy to actually go from the solid phase to the liquid phase. Evaporation. So a glass of water, it takes energy to make that liquid go into the vapor form. And sublimation. Please remember, sublimation is going from a solid to a liquid, and I'm hopefully going to bring in some dry ice for you so you can see that dramatically happen. So notice it takes energy to go from a solid to a gas phase. In these transitions, we're going from low potential energy to high potential energy. So please note that you're producing actually a cooling effect by this. You might notice when you get out of the shower, you're actually cold. Your skin feels very chilly, and that's because with evaporation, it's a cooling effect. It's not a warming effect. Okay, the opposite is exothermic, so heat is being given off. Freezing is exothermic. Condensation, so when you notice your car window outside overnight, you see water droplets forming on it. That is exothermic. Deposition. Deposition is going from a vapor to a solid. So for these, we're going from high potential energy to low potential energy. Energy is being given off. So this is actually a warming effect. You might notice that you're warmer inside the shower because the water vapor is condensing on your skin. Okay, so how does this apply to phase diagrams? Notice that a phase diagram, and this is very important, the units on the phase diagram are pressure versus temperature. So we can do some pretty amazing things with just changing the pressure or changing the temperature. So in a phase diagram, notice that on the x-axis, we're looking at temperature, and then at the y-axis, we're looking at pressure. Where you see the different phases meeting, this is called the triple point. And the triple point means that all three phases can exist together at that pressure and temperature. But notice as you increase temperature, you're potentially going from a solid to a liquid to a vapor. If you increase pressure, you could be going from a vapor to a liquid or vapor to a solid. Okay, so let's summarize. Intermolecular forces, they tell us how the attractions may affect viscosity or cohesion or adhesion. So we're looking at hydrogen bonding versus dispersion forces potentially. Crystalline solids, so we look at how they are classified, and that basis is on ionic, covalent, or metallic bonding. And then lastly, energy changes occur with phase changes, and these phase changes actually rely on pressure and temperature changes.